So the last bit of this topic is we're going to be looking at our dividing through by the denominator, but with a little twist. We're actually been asked to do something else, and that is to then find any values of x where the tangent is horizontal. So that is by letting dy dx be equal to 0, as you should remember. So let's jump straight in and have a look at how to do these ones. So we're going to start off with one that's not got any fractional indices in it, but it's just to get us in the idea of how we're going to be solving these. So let's have a look. We've got y is equal to x squared minus 4x plus 9 all over x. So what we're going to do is we are going to rewrite this as y is equal to, and we're going to divide through by x. So it's going to be x minus 4 plus 9 on x. Okay. So by doing that, we can rewrite this as x minus 4 plus 9x to the power of negative 1. Okay, so that now when we differentiate this, we get, so derivative of x is just equal to 1 minus, well, the 4 disappears, but then the negative 1 is going to come down the front, and it's going to make it negative 9x to the negative 2, like that. Okay, so once we've done that, we can rewrite this as 1 minus 9 on x squared, okay, by putting the fraction, or the indices down the bottom. Okay, but now we want to make it have a common denominator. We want to put this all together, because when we're finding the zeros, it's going to make it much easier if we do that. So what we're going to do is we're going to make a common denominator, x squared over x squared, by multiplying the top and the bottom of the left-hand side by the x squared, and it's going to give us 9 over x squared, so that when we put it together for the derivative, we get x squared minus 9 over x squared, like that. Okay, so we know now that we need to work out where the horizontals are. So we know that the tangent is horizontal when dy dx is equal to 0. So that is 0 is equal to x squared minus 9 on x squared. Okay, now this fraction is only is only 0 when the top part is equal to 0, okay? Because we can't have the bottom be equaling to 0, because if the bottom is equal to 0, then it's undefined. But any fraction is equal to 0 when the top of it, the fraction, is 0. So therefore, we need 0 to be equal to x squared minus 9. Now, factorizing this, it's a difference of two squares. So we get 0 is equal to x plus 3 and x minus 3. So therefore, the tangent is horizontal when x is equal to 3 or x is equal to minus 3. And what we can do is we can actually have a look at the graph of that to double check that. So we've got y is equal to, and we're going to put the original function in. So it's going to be x squared minus 4x plus 9. Okay, and that's going to be all over x. And so as you can see, where we've got x is equal to 3 here, we've got our first horizontal tangent at y is equal to 2. So if I put that in, y is equal to 2, there it is there. Now our second one was at minus 3, and you might be thinking, well, where is it? There it is down there. So we just have to scroll down a little bit further. So if we move it down to that value, which is at negative 10, that makes our tangent there. So our two tangents are at y is equal to 2 and y is equal to negative 10. So what we're going to do now is we're going to move back to the other screen, and we're going to have a look at the second one. And for some reason, my screen has now stopped mirroring. So we'll put it back on like that. Okay. So, just a reminder, we know that tangent is horizontal when dy dx equals 0, so we just make it equal to 0. If we move the x squared across to the other side, it's 0 times x squared, so the other way to think of it, so we get 0 is equal to x squared minus 9, and then we just solve it from there. So looking at part B says that we've got y is equal to 15x minus 5 over the square root of x. What we're going to do is we're going to now rewrite this as 15x minus 5 all over x to the half. So all over x to the half. Okay, and now that we've got that, we're going to write this as y is equal to. Now I've got 15x divided by x to the half, so this is the same as 15x times, or x to the power of 1 times x to the power of negative half, minus 5 times x to the negative half as well. Okay. Now using our index laws really quickly, if we're multiplying two indices, we're going to add the powers. So it's going to be 15x to the 1 half minus 5x to the negative half. Okay, so that's our function. Now we need to find our derivative so we can find the horizontal or the tangents. So dy dx is equal to, so 15x, so we're going to take the half down the front, times 15x to the negative a half, and we're going to subtract that from, so the negative a half is going to come down, so it's going to become plus, so plus a half, and it's going to be 5. Oop, I'll just redo that quickly. So it's going to be, so plus a half times 5x to the, I'm going to subtract 1, it's going to be negative 3 on 2 in this case. So dy dx is equal to, putting it together, we're going to get 15 on 2, and we get the x to the negative a half, plus, so a half times 5 is just 5 on 2, and that's going to be x to the negative 3 on 2. Okay, and now putting that next step together, we get dy dx is equal to 15 over 2 square root of x plus 5 on the top. Actually, no, we're going to leave it as a fractional indice, I think. So over half to x to the half, I should say, over 5 lots of 2x to the 3 on 2. Okay. Now, what I'm going to do is I'm just going to rewrite this a little bit to make it a bit easier. So this is like the trickier question of the day, I should point out before I jump into this little hard bit of algebra. Okay, so we've got this side, but on the other side, okay, I've got, and now the reason I'm doing this, it will come clear in a moment, is I've got 2 to the x to the half times x. Now the reason why I'm writing it like this is because I want to make the denominators the same, like I did on the other side, so that when I solve it, it's much easier. Okay, so to do so, what I'm going to do is I need to multiply the left fraction by x on the top and on the bottom, just so I get those denominators the same. So dy dx is going to be 15x over 2x to the half times x plus 5 over 2x to the half times x. Okay, now that I've got that, what we can do is we can make the fraction on the bottom the same, the denominator's the same. So they're both going to be 2x to the 3 on 2, and on top we're going to have 15x plus 5. Okay, so just like before, to find the horizontal, we're going to let dy dx be equal to 0. So that is, we can rewrite this as 0 is equal to 15x plus 5 over 2x to the 3 on 2. It doesn't really matter in this case. Okay, so again, just like before, we know this fraction is going to be 0 when the top of this fraction is 0. The alternative way is to rearrange for x. So what we're going to do first is multiply both sides by 2x to the power of 3 on 2. And we're going to get 0 is equal to 15x plus 5. Okay, so now that we've got that, we can substitute. We can rearrange for the x. So we're going to get negative 5 is equal to 15x, and that means that negative 5 on 15 is equal to x, or when x is equal to negative a third. And that's going to be the value at which our horizontal will turn around. Okay, and again, we can double check this one by putting our function in. So we've got y is equal to, let me just quickly scroll back up on my screen. We've got y is equal to 15x minus 5 all over square root of x. Okay, now it doesn't look like much is happening, but if I can work out where the negative a third is going to be. So if I take it all the way out, it kind of looks like it's going to go on forever down there. But what we'll notice is that, well, actually it does look like it's going on forever. That solution is correct, where the x is equal to a negative a third, so it's something really, really close. Let me go back this way. So there should be basically a number between here and here where our function comes back up. But regardless, this is our function. This is where the horizontal point is. Okay. And like like the example is similar to the one that's in the text, and it's the same. It gives us a very similar solution to that one as well. With that being said, that's it for this lot of videos. Okay. Next, we're going to be looking at the product rule, I believe, and then the quotient rule to finish off this week. So with that being said, happy driving.